These two questions are dealing with dilations, but they're unique because they're being dilated from two different centers. This center is 2 comma 4 and this center is negative 4 comma 5. So that's going to switch things up a little bit. So in this first example we have triangle ABC already graphed, which is nice, and the center's even called out. It's 2 comma 4, and we want to start dilating each of these points. So I'm going to start with C because it was closest to our center. So instead of counting the distance that C is from our origin, 0 comma 0, we're going to count the distance that it's from this center. So from the center, it looks like we're moving to the left 1, 2, 3, 4 times. So we're moving left 4, and then we're moving down twice. So down twice. And then we multiply both of those movements by our scale factor. So 4 times 1/2 is going to give us 2, and then 2 times 1/2 is going to give us 1. So from our center, we're going to move to our left twice and then down 1. And it's important to point out that this is not a point like 2 comma 1. It's just our distances from our center. And then I could label this. This should be C prime. Okay. Now, because we have a triangle, we could actually take the distance of AC, which is 1, 2, 3, 4, 5, 6. This distance is 6. And all we have to do is multiply that distance by our scale factor of 1/2. So 6 times 1/2 is going to be 3. So now the distance from C prime to A prime is just going to be 3, right? Because we have triangle ABC. That's going to be similar to triangle A prime, B prime, and C prime. So all these side lengths will have the same ratio, which is a scale factor of 1/2. Now all we have to do is find B prime, right? So we could measure the distance from our center to point B. That would be one way to do it, and that's how we started this problem. That's what we did right there. Or we could multiply the change from C to B by our scale factor. So this will give us a different way to even do these problems. So from C to B, it looks like we go down 1, 2, 3, 4, 5, 6. So we're going down 6, and we multiply that by 1/2 to give us 3. And then we move to our left twice, so our left twice, but we only want to do half of that. So 2 times 1/2 is just 1. Now I'm going to go from C prime, and we're going to move down 3 times, and then to the left once. Okay, and we're just going off of these movements here, right? Because we were originally going down 6 and then to the left twice from C to B, but we multiplied those distances by 1/2, and so we're really going to go down 3 and then over 1 from C prime. And I could connect all these points, and that's going to give me my new triangle. And to test this out to see if it's the true reduction from our original pre-image, what we could always do is run a line through our points and see if they go through the center. So from C to C prime, we run a line like that, and then from B to B prime, we run a line all the way through, and then from A to A prime, we're going to run a line all the way through. And as you can see, it's harder to do it on a computer, but it looks like they do all go through that center, so we're good to go.